Welcome everyone to the channel, and in this video we're going to go over a specific problem about falling down NPCs. So if you have ever played GTA or Red Dead Redemption, then you might encounter this phenomena right here. Whenever the player tries to collide with an NPC, it stumbles and then sometimes it falls down due to the pressure or maybe a bit of big collision. And huge thanks to Zerv for bringing my attention to this. And in this video, we're going to try to create that functionality inside the Unreal Engine using physics control. So first of all, before we do anything else, we have to go inside plugins and enable few of the plugins. So firstly, search for motion matching. Not motion matching, motion warping. And over here we have two types of warping. There is animation warping and then there is motion warping. Enable both of them and restart your project. Once you have done all of those things, we're going to go over to our PP third-person character. Right here we have few events that does the simulation and desimulate our character. Okay, if you want to know how we got to this position or how I created all of these events, you can check out the last video, how to make Ragdoll using physics control. Okay, so once you have all of these things, then we can start working on the AI. First of all, to create the AI, we are going to go inside the BP player third person, and duplicate it. And it's going to be BP AI. Okay, and we're going to give this AI a task to do. Okay, so inside the begin play, we're going to say AI move to, and now we can add a pawn which is going to be self. We want the AI itself to move to our player character, so get player pawn. Okay, so with this node, now the AI will start chasing us. Also, for the AI to know where it can walk and perform some actions, we need a nav mesh. And you can add a nav mesh by going over to the place actors and search for nav mesh and drag the nav mesh bound volume over to the world. Okay, so wherever you want to put it, you can, and then you have to scale it. As you can see, this is my nav mesh volume, and you have to scale it so everywhere that you want your AI to move to is covered. And if you want to test out where the AI can move, if you want to see the path itself, then you can click on P. And once you do so, you will see a green path appear in front of you. And this green path shows you where the AI can reach and stand on its own. Okay, so if you give it a command to go over to this location right here, then the AI will walk from, let's say, from here and find the shortest path to get to this position and then stand there. Now the next thing that we want to do inside the AI is on success, when the AI has reached the player. Okay, in other words, this means that AI has collided with us. Okay, so let's just visualize it by placing the AI in the world, and as you can see, the AI is colliding with us, and now it stopped because we are not giving it any information further than going to the player. Okay, so now what we want to do on success, we want to create an event where the AI will stumble. Okay, so right now I have few animations. Okay, so I have these animations with me which I got from Maximo and retargeted them to the UE5 mannequin. And all of these animations, because they are from Maximo, you have to give them the credit inside your game credits or film credits, wherever you want. Okay, so that's the only thing that you need to keep in mind. So now what we have is a backward animation. Okay, and this is just a simple animation which is a drunk guy running backward. Okay, but more than anything, it looks like he's actually like something, someone or something collided with it, and now he's just trying to gain his balance and also traveling backward, which is kind of similar to what we want to do. Okay, and there is nothing else beside you have to enable the root motion and normalize root. Okay, so make sure that both of these things are true and you have this animation in your system. The next thing that we are going to do is I'm going to actually create two animations from the same animation. One is of him running forward and one of him running backward. And how I able to achieve the backward and forward motion is by going over to this rate scale right here and make it -1. Okay, so it's going to be -1. And when you do that and try to play the animation, now it's playing backward. We want to keep it as 1. And now there is this little thing over here. This is called a montage notify. And what it does is at a certain frame, in this case frame 59, this notify will launch a signal into the system, and wherever the animation montage is running, that a fall can occur. Okay, or a message called fall has occurred, and we can use that message to perform some actions at certain point in the animation. Okay, so that's the only thing that we are trying to do here. So this, and you can create it by going over to here and create a new notify track and right click, go to the add notify, and then add a montage notify. Okay, no new notifies but a montage notify. And then you're going to have this kind of notify where you can add a few things. We're going to go inside this notify option and change the notify name to anything that you want, and make sure that you remember this name or copy this name in future when we are going to use it, because this is case sensitive and character sensitive. All right, and the other thing, the reason why we included motion warping is to include this motion warping notify. Okay, and what we are going to do is again create a new notify track by going over to tracks and add a notify track, and then we are going to right click, go to add notify state, and over here you will see motion warping, and this is a basically a time frame, okay, on how long that you want a notify to happen. Okay, so rather than being just one frame in the rather than being one frame just like the motion notify, this is going to be a time frame. Okay, so it's going to contain multiple frames rather than being just one. And what we want to do in this particular animation, we want to make this motion warping in the complete animation. Okay, it's not going to be a certain particular part of the animation, but it's going to include the whole animation itself. After that, once you have created a motion warping state, then we're going to go over to the details and select over here in the root motion modifier to be skew warp. Okay, and then we're going to expand this, and inside the warp target name we're going to give it a name. Okay, it can be anything, but again this is a case sensitive and character sensitive, so you need to have it remembered or copy it. Okay, so right now we're going to, let's say, name it to be, what do I have over here? Stumbling. Okay, so you can also call it stumbling. Okay, and whenever you call for stumbling inside your blueprint somewhere else, the motion warping node will know that you're talking about this particular frame right here. Okay, so now that we have all of these things setted, we have a motion warping node going through the whole animation, and we have a fall occurring at 60 frames. Okay, 60th frame. This fall needs to occur at 60th frame. If you are working with me, you have to make this animation occur at 60th frame. Okay. And then we're going to work on some blend in and out. I have put it the blend time in both of them to be 0.2 and the mode to be hermit cubic in and out. Okay. And once you have the animation montage setted, you're going to come back to animation PPAI, and upon success, when we have collided with our character, we are going to do motion warping. But before that, we have to add motion warping here. So add motion warping. It's a component and we need it to have the motion warping nodes and algorithms. Okay. So inside the motion warping, we're going to drag out and call for add or update warp target from no, it's just update. Let's go with update. Okay, it's going to be this node right here, add or update warp target. Okay, that's it, and it's going to happen upon the success of this AI move to. We're going to right click and split struct the pin, and now we're going to change few variables over here. So first of all, this variable, the warp target name, is going to be the same name that we put it over here in the skew warp, which is stumbling. So make sure that you put it correctly. So stumbling, and then we have the warp target location. Now, how do we actually get the warp target location and what it should really be? Let me show it. Let me show it to you. So let's imagine that this is our AI. Okay, so this is our character and this is our AI. Let's just imagine that. Okay, and what is actually going to happen is that this AI is traveling towards us, and then it hit us and then fall back. Now, as you can see, that the fallback location of this actor itself is kind of the opposite of the way it is coming towards us. Okay, so basically the location that we want this character to move to is going to be let me just make it much more clear. So let's say that there is a point in our character and then there is a point at our AI. Okay, and when we create a line between these points and exceed that line further behind the AI, somewhere on there on that particular line is going to be our location. So let's imagine that we have a point in a world where our character is running. So this is the player or a target where the AI is trucking at. Okay, so this is our player. So this is our player, and then there is an AI coming towards it. Okay, so let's say that the AI is, so let's imagine that there is an imaginary line connecting both of these things. Okay, there's an imaginary line connecting both of them. Let me make it a different color. So there's an imaginary line connecting both of them. And what we have to do here, what we have, like, how are we going to get the location where we want to work to, is using this imaginary line. Okay, so let's imagine that this line have arrows, or let's imagine that this line have some kind of electrons that we are sending from the player to the AI. Okay, so that electron is going that way, and that way, and let's say that it passes through the AI and move even further. Okay, something like that. Now, a line in particular can do this. A hypothetical solution-wise line can do this, and we can get a location at certain point behind the AI relative to our player character. So how we are going to do this is, first we're going to find this particular line, and then we are going to add some amount, let's say 100, into it, from which we're going to get the whole line and the actual location of the work target. So now that we know what we want to do, let's do it. So first of all, we're going to get the player location from our player pawn. So get actor location. So this is going to be our starting point. Then we're going to get actor location again. This is going to be the AI's location, which is going to be our midpoint. Okay, and what we want to do is we want to have a unit direction. Okay, so we want to get a unit direction from the player actor to the AI, and we want to add or multiply it by a float of, let's say, 200. Okay, and this is going to be our location. Then our rotation is going to be same rotation as our AI, so it's going to be get actor rotation, and put that there. Other than that, you don't have to change anything else. After this, when we have completed the update warp target, we're going to play animation montage. Not this one, the play animation montage, this one. Then we're going to add our mesh to the in-skeleton component. The montage we're going to play is the backward, and we're going to now do a few things with these outputs. So first of all, we're going to grab the notify name, and over here we're going to switch on name. Okay, and it's going to be happening at the notify begin, and there will be no default pin but one pin which is going to say fall. Okay, again this have to be same to same as you mentioned over here in the notify. Okay, now that whenever in the animation it's going to say that we are falling, or a fall message has run, this node will perform some kind of action, whichever we put it to. Okay, so now what we want to do is create a branch, and this branch will have a random bool, and now we are making it random. The reason why we are making it random is because sometimes the AI is capable of balancing itself. Okay, Okay, so if the random boolean is true, which means that the AI balanced itself. AI was able to balance itself. Or if it's false, that means that the AI fall down. Okay, so that's the difference that we want to get, and I'm just putting it on random because it is kind of a good way to randomize it. Like sometimes the AI falls, sometimes it balances itself and stays still. So we're going to do that. So the fall means over here we're going to comment true equals to balance, false is equal to fall down. Okay, and now what we want to do here is if it's true, then we are not going to do anything. Okay, we're going to do it after we have completed this whole animation. Okay, so if it's true, we're not going to do anything, but if it's false, then we're going to stop animation montage. Okay, so if we are about to fall down, then we're going to completely stop any montage and a particular montage that we are doing, and the montage is going to be the same montage that we are running over here. Okay, so now that is done, now we're going to just create some kind of loop so that it does this kind of thing every time over and over again. Okay, so firstly on fail we're going to give it a delay. So after a delay of, let's say, few seconds, it's going to try to come back to us and move to our player character again. Okay, so this is the first loop. So if the AI fails to reach the player, then it's going to try again and try again to reach the player, and if it fails again, then it try again, but with a delay. Okay, and if we succeed and if we complete it, if we complete the animation, and it's going to be the same thing. It's going to be the same branch with the same random bool output, and at this position if we succeed in this, okay, okay, so if we complete it and the AI balance itself, which means it's true, then we're going to go back and try to chase the player again, just creating a basic loop functionality in our AI. Okay, and let's say that it falls. Let's say that it is false. Well, nothing is really going to happen because it's going to be interrupted. We are stopping the animation and we are not actually completing the animation, so we don't really have to do anything inside the false. So now that is done, we need to again create this stop animation, and that means we are falling down, which means we need to be in a ragdoll state. Which means that we need to perform this particular action, this launching ragdoll. Okay, so we're going to drag this, put it over here, and attach this to the simulation. Okay, and that's it. After 5 seconds or so, it's going to end the ragdoll, and after it ends the ragdoll, which means over here when we can move, what we're going to do again is we're going to launch and try to move to the AI again. Okay, so basically what is happening, let me visualize it. So our AI, let me make it blue. So we have our player, okay, and then we have our AI. Our AI goes towards the player. AI move to, it collides with it. Okay, so the AI collides with the player. Okay, so it kind of collides with the player and it sends back, it goes back. Okay, so it stumbles, it's trying to balance itself, and sometime it falls down. Okay, so right now it's in complete ragdoll state. Okay, after that, after 5 seconds, it's going to get back up. Okay, something like that. And once it reaches a point where it can move again, which means it's completely stand up, and it's going to do this loop again, and it's going to try to reach the player again. Okay, there's another type of loop, which is basically when it collides with it, it's going to stumble. Okay, and then it's going to balance itself normally. Okay, it's going to reach a balance, and if it does so, then it's going to go back and loop back, and it's going to chase the player again. So this is this basic algorithm that we are working on, and now we're going to compile and save and check if it is working. So the AI, okay, that was a problem, and now it's not even trying to come back to us. What happened? Wait a minute. Yeah, unique direction is basically which way we are facing. This is not exactly a good way to visualize anything. This is basically which way we are facing, or which way is that particular line moving. But we need the start location to be something else, which means we need the start location to be the actor location, and we want to add, okay, we want to add this 200 to this, and this is going to be our warp target, and this is going to be our end, and let's visualize that. See, boom, it's working, it's working. When we are doing this montage play, we want to get the can move, and we will stop it so that the AI will not be able to move while doing the animation. So as you can see, sometimes it falls, but sometimes it balances itself, which is kind of great. Okay, it's still trying to move, which is weird. So probably the reason being is this random bull. I think it is inputting random things in both of them. It's not the same branch anymore, I guess. We can do one thing, and that is on false. We're going to do once. We're going to do once. It's going to start, close, and it's going to reset every time we are running this animation. Okay, and also first the can move is going to go, and then it's going to reset it, and yeah, something like that. And then the branch is going to be the same branch as before, or same bull as before. And this random bull, we're just going to get this over here. Right click, promote to variable, well AI 4. Okay, so we have this boolean no, or we have this particular variable when we are trying to like update stuff and when we actually reach the player. Okay, so as soon as we collide with the player, the AI will figure out if it will fall or if it will not fall, basically. Okay, so if it will fall, we want to do something else. We can have different branches now and no do ones. So it could go here and different branch, not this one, could go here. Nice. Okay, so I think that is going to fix when we are not like able to go back to the player again for some reason. Now let's try it. Sometime it falls down and get back up, then get back up, but sometime just stumble back and balance itself. Okay, nice. Now there is one thing that is going to amazed me while I was testing all of this. And let's say that now our player actually does try to reach, try to collide with the AI. Okay, first of all, let's disable the camera. So PPAI collision, no camera collision, and also with the capsule, no camera collision. Okay, so now if I try to actually intentionally push the AI, look at the reaction. And this reaction is kind of too pure to be in an animation. Okay, so this reaction is too pure to be in a animation, and this is why again the physics control is such an amazing thing, because it creates these dynamic animations and dynamic poses for our characters, so that we can have such amazing things. And now we have a basic system that you can now enable, right? You can basically have a system that whenever the player collide with the AI, rather than whatever we are doing right now. So right now, the AI is trying to reach the player, and if it collides with us, it does this. But rather than this, you could do it that the AI is not exactly chasing us, but just minding its own business. But as soon as we try to collide with it, it does that. Okay. All right. So instead of this, maybe we can have a sphere collision. Okay. And we can increase its size. So whenever our player, okay, so the player actor, whenever it overlaps with this, the AI will do its thing. Okay. So on component begin overlap or on component hit. We're going to go over here, check whether the other actor is equal to our player pawn. Okay, so we first going to check that, and then we're going to make a bool branch, and if it is the actor, then we want to do this. Okay, let's do it. Hold down. Just hold down. Okay, we need to test something. Is it print string? Are we even colliding with it? No, we are not. Are we colliding with it at all? No, we are not. Why is that? I don't really know why is it doing it, but we are not able to collide with anything here. So let me just increase its size to even more. Oh, nah, it's not like that. It just overlaps all the dynamics. So let me just increase its size. And now let's see if it does anything. Okay, nothing. What about if we have, instead of the hit, the on component begin overlap? Okay, now it's working. Okay, so it was this node on component begin overlap, and we want to check if the other actor is the player pawn, and if it is, then we want to do it, and also let's decrease the size. Okay, now it's a bit buggy. It's not that fluid as before. And now it's trying to, okay. Okay, so oh yeah, it's running multiple times. That's the problem. It's doing the thing too many times. Okay, let's fix that. Go back to the AI, and over here inside the branch, we're going to make it do once. Okay, and it's going to be completed and come over here, and we're going to reset this do once when we have completed the node. Okay, so not like this. Yeah, we're not even using this anymore, right? Maybe we are. Okay, so even if it is false, so sequence, or even if it's true, nah, what am I even doing? Add a reroute node here, and over here we're going to add a sequence, and then we're going to attach it over here, and this will be attached to the reset. Okay, so now what I have done, not exactly in false though, so it's just going to happen inside true. So if the player completes the animation and it is standing, okay, it is standing on its feet, only then we want to reset it. Or if we came over to this position over here and now we can move, then we're going to reset it again. Okay, so basically when we are doing the AI move to on whatever positions we were doing AI move to, Now we just need to connect all of those position to the reset node as well. Okay, and I think that is good enough to make it fold down. I'm going to try to push him off of this. Okay, he didn't fall. um, um, okay, go down, go down. Nice. Okay, so that is our stumbling and basic things. Now, what you can do in this position is you can set few conditions, like it can only fall down if it's not trying to fight us, and it can only fall down if it's not like in a active state and it's just like standing or walking somewhere. So you can create all of those situations, and you can run this or not run this based on those situations. Okay, and we can also remove this AI move too. And now if we try to play, now as you can see that the actor is still standing, but if we try to collide with it, it falls down. Okay, so now the actor is not trying to reach us, it's just standing, the AI is just standing, but as soon as we collide with it, it falls down. Okay, so it could be same as if the AI is following some path. I don't have much time to showcase the path creation, but let's say that the AI is following a path and we happen to run into him like this. Then the AI will get out of the way. First thing, it will get out of the way, and then it will fall down. Or maybe the AI is too stubborn to stubborn stubborn to move out of the way. Yeah, so you can do that. Now there is one bit of problem, is if we're trying to hit him from the back, right? Then it does this thing, which which is not good, and that is what we're going to fix right now. So let me clean up this mess. Okay, so now what we want to do is we want to select which kind of animation are we actually playing. Okay, so we're going to drag from the montage play and we want to select it. Okay, and this selection is also the selection that we want to input over here. Then in truth, I'm going to run it backward. Okay, so the positive is going to be the forward and the negative is going to be the backward. So this is full motion warping. Everything is done. Over here we actually run from the back, so it have to be something like this. Maybe it's because of the rate scale. How about I duplicate this one, duplicate, make the sequence rate scale to be -1, save it, and make a montage of this. Okay, so over here, as you can see, the animation is actually running in positive scale inside this montage now. So now we can add another track, and in the first track we're going to add motion warping in the full animation, skew warp, and the name is going to be stumbling. Okay, so right now we go forward, forward, forward. I think the fall should be somewhere over here rather than there. Yeah. If the player is going to fall, it should fall over there. Like this. Nice. And now it can get back up. Okay. A bit of problem inside the calculation that I was trying to do, and it's not behaving as we want it to. So what I'm actually going to do is delete all of this, and in the index of true and false we're going to check it by using a collider again. So we're going to have a box collision. Okay, and this box collision is going to stay behind us, like something like this, and it's going to determine if if the player is behind us or in front of us. Okay, basic thing, pretty good for what we want to do. So on component begin overlap, we're going to get the okay, so now that we get, so now we're going to change this boolean value if we are being pushed from the backward or from the forward using this. And whenever our character will begin to overlap, we're going to go over here and make this true. Default is going to be false, and on component begin and overlap. So go back to the box, and on the end overlap we're going to get this and set it to false, and go back here and attach this. So now this ran the backward one. Okay, change in here as well. So pushed from back is going to run backward 2, and either is going to run backward 1. Okay, and if we attack from front, at last. Thanks for watching, and see you in the next video. Bye bye.